Now I want to share with you what is the role of the binomial distribution in the problems of the probability. Actually, for solving the problems of the binomial distribution, these problems are applied only if we have a large number of trials. Suppose x is equals to r, probability of getting x random variable, how many times it is required as r, and n is the number of trials. Then formula for calculating the required probability by using the binomial distribution is NCR into p is to power r, where p is the probability of occurrence and q is to power n minus r, and q is the probability of non-occurrence of the same event, or you can say q is 1 minus p, or you can say p is 1 minus q. So, for the binomial distribution, we are required to use the result pxr. X is the random variable with which the problem is associated, r is the number of times which is related to us, and n is the total number of trials, where p is the probability of occurrence and q is the probability of non-occurrence. So, this formula NCR p is to power r, q is to power n minus r is required to remember for solving the problems of the binomial distribution. Now, I want to discuss with you here r can be 0, 1, 2, 3, a problem. With the help of that, you will get to know how to apply and when to apply the result. A die is thrown 6 times. A die is thrown 6 times, that is 6 into 6 into 6 into 6 into 6, 6 times. So, total number of sample space will be 6 is to power 6, a big number, a large number. Here we will use the binomial distribution. And this 6 is the total number of trials. That's why we will say yes, n is 6. N is the total number of trials in this formula of the binomial distribution. So, answer of n is 6. A die is thrown 6 times. If getting an odd number, when we are rolling a die, then what is the success? The success is an odd number. Suppose on the rolling of die, we have rolled it how many times? 6 times. What is considered as the success? An odd number. How many numbers are on the face of the die? 1, 2, 3, 4, 5, 6. Out of these 6, if any odd number, either 1 or 3 or 5, if it turns, we say success. If doesn't turn, we say not success. So, a die is thrown 6 times. If getting an odd number is a success, what is the probability of getting 5 success? 5 success means out of 6, 5 times we have got odd number. At least 5 success, minimum number of success is 5. At most 5 success, at least 1 success, or no success. So, for this we will use the binomial distribution. It's very much clear that probability of calculating will be applied here. Let p is denote the success, that is the p is the probability of occurrence. In one time when we roll the die, we obtain 6 situations, 1, 2, 3, 4, 5, 6. Total number of cases is 6. Out of these 6, 1, 3, 5 are odd. So, we can say the probability of success, that is p, is 3 are the favorable situations, odd numbers out of 6. So, 3 by 6 it become 1 by 2. And q is the non-success. Q is what? 1 minus p, that is 1 minus 1 by 2 is half. Answer of p is half, answer of q is half, n is 6, total number of trials is 6. We have n, we have p, we have q, and the result is required to use is NCR, p is to power r, q is to power n minus r. Here n is what? 6, CR. P is what? Success, half, is to power r, into q is what? Non-success, non-occurrence is also half. That's to the power n minus r, means 6 minus r. So with the help of this situation, which is obtained from the given situation, we will solve all 5 parts which are required here. That is how we will get the 5 success. So for 5 success, we will replace R by 5. Now for first part, for 5 success, as formula is told you, it is NCR, P is to power R and Q is to power N minus R. Here N is 6, P is half, Q is half. For 5 success, we will use R as 5. So for 5 success, NCR, that is 6C5. P is to power R, that is half is to power 5, and Q is also half. Q is to power N minus R, that is half is to power 6 minus 5. This becomes 6C5, half is to power 6 because it is half is to power 1, half is to power 5. This together become half is to power 6. Their calculation will give us 3 upon 32. This is for the 5 success. Now for at least 5 success, if we talk about for the at least 5 success, it means we have to calculate for 5 success or more than it. That is either 5 success or all 6 successes. It means that OR word is coming, that's why we will use the plus symbol. For 5 success, 6C5, half is to power 6, plus for all 6 successes, it is 6C6, half is to power 6. Reason being, we are using the same result NCR, P is to power R, Q is to power N minus R. For using R as 5 here and using R as 6, it is also NCR, P is to power R, Q is to power N minus R. For at least 5 success, we have to calculate, we have to get 6C5 half is to power 6 plus 6C6 half is to power 6, that's net value will calculate, give you 7 upon 64. If we talk about the third part, it is at most 5 success. At most 5 success means what? 0, 1, 2, 3, 4, 5. It means that 1 minus only 6 successes to be removed, because calculating 1 0 success, 1 success, 2 success, 3 success, 4 success, 5 success is ultimately we can calculate 1 minus all 6 successes, that is 1 minus 6C6 half is to power 6, that is what? 63 by 64. Now if we talk about the fourth part, it is what? At least 1 success. For at least 1 success, we can say 1 minus 6C0 half is to power 6. At least 1 success. That's why we will say either 0 success, that is what, or 1 success. So it is 1 minus 6C0 half is to power 6, which gives us 63 by 64. And the last part, no success. It means that R will be used as 0. So 6C0 half is to power 6, it is 1 by 64. So this way we can use the binomial distribution by taking care what is N, what is R, what is P, what is Q, and how in shortcut for at least and at most we can use this data.